Dear students, today we will discuss about gravitational field and gravitational field intensity. So in the last classes, maybe if you observe, we discussed about Newton's law of gravitation. Newton's law of gravitation. F is equal to G m1 m2 by r square. And after that, superposition principle we discussed, right? So according to the principle of superposition, the total force is equal to the vector sum of the individual forces. Vector sum of the individual forces. So now today we will discuss about gravitational field and gravitational field intensity. So we'll try to understand. See, write down. Gravitational field. Generally, how we define gravitational field. So when we in class 12, when we are in class 12, again the same topic will be there, but the word will change. Electric field, magnetic field will be there. But further, for all the fields, the same definition. For all the fields, same definition. Either it is gravitational field, electric field, and magnetic field. It is same definition. So before going to discuss about the definition of gravitational field, just we will discuss a small example, right? So that we can understand easily. Clear? So for example, here I am saying that here one student is there. For example, here one student is there. The student is having his own house, and a nice house it is, own house, and he's staying and he's having some compound. We know already every house having its own compound, correct? So now he is sitting here and he is somewhat strong, and again here he eating laddus. What he is eating? He is eating laddus, right? Just for example. Now I am the person, second person. So I went here, and in my hand one rod is there, which is used to dig, correct? So here one rod is there. With that I am digging some here. So he knows me, and I am digging there, and he is asking, sir, what you are doing there? Because he is very good person, he is very good student, and he asked, sir, please tell me what you are doing. Then I replied in a bad manner, do your work, why you are involving me, like that one, this one, I told like that. Then he felt somewhat bad, right? Generally everybody will feel bad if a known person will say like that. Again he started his eating, correct? He felt bad now, so with that he started more eating. So now I stopped here. Again I came here, and again I am digging here. Again I started digging nearer to the fencing, and again he is observing. He want to ask. Again he thought, if sir will say anything, why I want to ask. But curiosity will be there, na? Curiosity. He asked me again, sir, you tell me, sir, what you are doing there. Then now I scolded double. What is the need? Why you are asking me, do your work, do this one. Why you are involving my work? Do this one, that one. I scolded a lot. And now he got angry. Very angry. And with that angry, he started eating more to build up muscles, right? He is eating. Then what I did is, I stopped here, right? And entered into the house. And I started digging. Where? Inside the house. Now you tell me, he will ask her, whether he will ask a question, sir, you tell me, sir, why you are digging in my house? Whether he will ask? No. No one will not ask, right? No one will not ask. But what he will do? He will lift me and he will throw me out. He will lift and he will throw out. Correct or wrong? Everybody will do. Right? Even though if I am in that position, I will do the same thing. I will not offer any coffee and tea, or you tell me why you are digging my house. No one will not ask. But the same thing, whether when I am digging here, he has no right. When I am digging here, he has no right. But when I entered into this region, then he threw me out. Correct? So here, what I did is I entered in his region. I entered in his region. I entered in his compound. When I entered into his compound, he shows his force. He shows his force. I hope you understood, right? One more example we'll see. One more example. See here, one positive charge particle is there. One positive charge particle. We know generally in class 10th also we studied, right? Like charges repel, unlike charges attract. Like charges, what they will do? It will repel. Unlike charges, it will attract. Now you tell me, I am saying that one charge is there, positive charge. It is in Delhi. It is in Delhi. And one electron is there. Electron, which is in, for example, we will say it is in America. One is in Delhi, one is in America. Both will attract. Both will attract? No, it will never. Right? It will never. For example, in this situation, see here, for this positive particle, I am drawing some compound. It is having its own region. Now, if electron is here, whether it will attract? No, it will not attract. For example, I am saying, here it is there. It will attract? No. When electron is entered into this region, then it will show its effect. What is its effect? Attraction. Electron is coming now, that's why come. It will say. When the electron is entered into this region. In the similar manner, when a mass or when a person is entered into his compound, then only he can able to show his force. So from this one itself, we can understand what is gravitational field. Gravitational field is nothing but the space surrounded by a mass. What is gravitational field? The space surrounded by a mass where it can show its effect. I hope you understand, right? The space surrounded by a mass where it can show its effect is called gravitational field. Out of the region, it cannot able to show. When the particle or when the mass, another mass is entered into this region, so it can able to show its effect. This phenomenon is called gravitational field. The space surrounded by a mass where it can show its effect is called gravitational field. So now I will write the definition. Please make a note. See the definition. The space surrounded by a mass where it can show its effect is called gravitational field. Right? Now we'll try to understand gravitational field intensity. Gravitational field intensity. Intensity is the measurement. See, for example, I am saying that here one mass is there. So we know according to Newton's law of gravitation, every body attracts every other body. Right? Now, for this mass, for example, here up to here the region is there. So in this region only it can able to show its effects. Right? So here one point is there at point A and point B. Now you tell me at what point A or B, at what point it will show its effects, more effects. What is the meaning of effect here? What is the meaning of effect? Force of attraction, right? Force of attraction. Now you tell me here attraction force will be more or here attraction force will be more. Think and tell me. At what point more force of attraction will be there, at A or B? Tell me, at A or B? Absolutely at B. Why? Because the point B is nearer to the mass. Point B is nearer to the mass. You may ask a question, sir, if it is nearer to the mass, how force is more? So we know F is equal to G m1 m2 by r square. So F proportional to 1 by r square. If distance is more, force will be less. If distance is less, force will be more. Clear? So here distance is less, force will be more, and distance is more and force will be less. Clear? But how we are defining gravitational field intensity? Gravitational field intensity at a point is defined as gravitational field intensity at a point is defined as force acting per unit mass. Force acting per unit mass. That means here, in order to find out the gravitational field intensity, first what we have to assume is, we have to assume a unit mass. Unit mass means, for example, let it be m. So now I have to keep the m here. After that I have to find out the force. Why? Because for single particle or for single mass, we cannot able to find out the force. Force itself the combination F is equal to G m1 m2 by r square. Clear? So for single mass, we cannot able to calculate the force. That's what I am doing here. I am considering a unit mass. Unit mass means whose magnitude is equal to 1. Mass is 1 kg. Clear? So when I consider mass here, small m, now first what I have to calculate? I want to find out the force between the two. So what is the force between the two? F is equal to G m by r square. G m by r square. Now what is gravitational field intensity? Gravitational field intensity at a particular point is defined as gravitational field intensity at a particular point is defined as force per unit mass. Generally, gravitational field intensity is denoted by small g. So I will write here small g is equal to gravitational field intensity at a point is defined as force per unit mass. Force already calculated. Force upon mass. So I will write the G is equal to force. How much we got? G m by r square, and again force upon mass. I will let small m here. This one will cancel. G is equal to Gm by r square. Which means the gravitational field intensity at that point or at any point does not depend upon mass at that point. Clear? It depends upon the mass of the one body. Right? It does not depend upon the small m. It depends upon only capital M. Original body, how much mass it is having. It does not depend upon the small m. Why? Because here small m, numerator, denominator get cancelled. Clear? I hope you understood, right? Gravitational field, the space surrounded by a mass where it can show its effect. Gravitational field, the space surrounded by a mass where it can show its effect. Gravitational field intensity means gravitational field intensity is always defined at a particular point. So gravitational field intensity at a point is defined as force per unit mass. So I will write here. So please try to understand. See here, what is gravitational field intensity? Gravitational field intensity at a point is defined as force acting per unit mass. And it is denoted by G. Gravitational field is a vector quantity. That's why it is G arrow. Clear? So now we can write G arrow can be written as force per unit mass. So we already calculated. So G can be written as, what is force? G m by r square into small m. So this one will cancel. So we'll get G is equal to gm by r square. Very, very important formula. Gravitational field intensity at a particular point is defined as force acting per unit mass. Clear? If you see here, it is a vector quantity. It is a vector quantity. SI units. What is SI unit? SI unit, force upon mass. Force upon mass, which means Newton per kg. Newton per kg, right? And if you want CGS units, you can write CGS unit dyne upon gram. Dyne upon gram. Clear? I hope you understood, right? So one thing we have to understand, very important point. For example, I am considering here one mass, capital M. For example, at that point, I want to find out the gravitational field intensity. Gravitational field intensity. So we have to understand that field intensity is nothing but force upon mass. So which force it is? Gravitational force. Gravitational force is attracting. So here, at that point, gravitational force is in this direction. Right? So in the direction of gravitational force, only the gravitational field intensity will be there. In the direction of gravitational force only, the gravitational field intensity will be there. That means in this direction only, the gravitational field intensity will be there. So it is very, very important point. Clear? I hope you understood, right? Clear? Make a note. In the next class, we'll discuss more about this gravitational field intensity. I hope you understood these topics, right? Thank you.